Okay, so we are on 6.8, ready, set, go. And we're going to be doing one of these problems here. Okay. And so when you're doing problems like this, they're asking you to find the missing side. Whenever you're doing this problem, I need you to go through a couple of steps so that you feel more confident that you have a lot of tools. So the first tool that I'm going to bring up is in right triangles, we have two tools that we mainly use. What are the two tools that we use whenever we're doing work like this for right triangles? No, one of them's Pythagorean theorem. Very good. Wait, I don't know how to spell Pythagorean theorem. Help. Erase. Okay, here we go. Pythagorean theorem. Okay. And the other one is trig. So for these ones, I can't use the Pythagorean theorem because in order to find the third side, I need at least two sides. So that means I'm going to have to use trig on these. Okay. So what we're going to do here is we are going to practice using trig. So the very first thing that I do whenever you are learning something for the very first time, it's okay to write everything out and then figure out which one you know how to do. So when I explained these in the past, that's exactly how I approached it, right? Um, so when we do this, so let's take number 12 for example. I'm going to start off with sine. I'm going to move on to cosine and I'm going to use tangent to actually see which equation produces an equation that I can actually use to solve for A. Okay. So what I want you to first do is I want you to write the sine of 35 degrees, the cosine of 35 degrees, and the tangent of 35 degrees. Oh, yes. But I was talking about sides. Someone said, Miss Johnson, we know 35 and 90. Yes, that means we can find the other angle. We can find the other angle, but we can't find the other side. So that's why we can't use the Pythagorean theorem. Okay, so I want you to fill this out. I want you to tell me what sine would be, what cosine would be, and what tangent would be. And then I want you to tell me which equation is going to be the most helpful in finding out which and solving for A. Yeah, we can't use Pythagorean theorem, right? Yes, we're doing number 12. So we can't use the Pythagorean theorem because the Pythagorean theorem says if I know two sides, I can find the third side. I don't know two sides. I only have one side. I only have 16, right? Very good. Someone told me which one I'm going to use. So I'm going to start using this. If you didn't know how to do this, don't worry. I'm going to walk you through. So what is sine again? What's the definition of sine? Very good. Sine is so, which is opposite over hypotenuse. Opposite? Oh, I don't know the opposite. So I can't use sine. So then I'm going to try cosine. Cosine is adjacent over hypotenuse. What's the adjacent side? Yeah, A. And then what's the hypotenuse side? 16. Very good. So that means I can use this equation. This is a good equation to use, right? And then I just try tangent just for fun, just to see if I could use it. And tangent is TOA, which means opposite over adjacent. And I can't use it. I can't use opposite because I don't have it. So this one's a bad one. Does that make sense? So now I'm going to use this equation to solve for cosine. So here it goes. It says cosine of 35 degrees equals to A over 16. So if I'm trying to find A, I need to somehow work with 16 and get rid of it so that A would be by himself. how would you get rid of that 16? How would you undo that? How do you undo? Yeah, you multiply. Why do we multiply? Yeah, because we're dividing. Very good. Okay, so here we have 16, 16. Remember that when you're multiplying by cosine, you want to take that number and pop it all the way out in front. So it's very clear to Miss Johnson when she's grading your work that 16 is in front of cosine. And then so now I'm going to write 16 cosine 35 degrees. That's my exact answer. And then I'm going to find you an approximate answer for using Desmos. Very good. Oops,
my
sorry.
first impressions were not great.
Oh my gosh, stop. Sorry, I thought that was my Desmos. You guys are like, Miss Johnson, what were you watching? That wasn't me. That would be my son. No, I don't want to split my screen. Sorry. All right, here we go. So I'm going to hit 16 cosine 35 degrees. Miss Johnson, don't forget to check if you're in degree mode. Oh no, I wasn't. Okay, so it's 13.1. So it's 13.1. So then I like to put 13.1 right here and see if that makes sense in that triangle. So in that triangle, doesn't it make sense that the hypotenuse could be 16 and one of the legs could be 13.1? Doesn't that make sense? Doesn't that make sense? Everyone's like, yeah, Miss Johnson, that makes sense. So this is how you solve a right triangle. Okay. And when I say solve a right triangle, it means find the missing pieces. Technically for me, when I say solve a right triangle, it means to find all the sides and all the angles. So the very first thing that I did was I chose which one I was going to use between sine, cosine, and tangent. Some of you are going to get so good at this that you don't have to actually write sine, cosine, tangent. You're just going to look at this triangle and be like, oh, so A is the adjacent side to 35 degrees and 16 is the hypotenuse. So adjacent and hypotenuse. Which one of those functions is adjacent and hypotenuse? Oh, that's cosine. So then you'd write it up as cosine of 35 equals to A over 16 and then solve. But if you're not there, your helper is going to be to write all of them down and then figure out which one works and then just solve like normal. Okay. Whenever you use a calculator, make sure that your mode is in degree, and then you should have like a really good, you should be able to come up with that correct answer every single time. Okay. So look at this. Where is the place that you're going to make a mistake? And then walk very carefully around that until you're comfortable with doing this over and over again. Okay.